Welcome back. Today we're diving into one of the most fundamental concepts in physics, motion in a straight line. Whether it's a car accelerating down the highway, a ball rolling across the floor, or even how you walk, everything moving in one direction follows the same rules. In this video, we'll explore what motion really is, how to measure it, and the mathematical laws that govern it. By the end, you'll understand distance and displacement, speed and velocity, acceleration, and even how to read motion graphs like a pro. So stick around and let's master motion together. What is motion? Motion is simply the change of position of an object with respect to time. But here is something important. Rest and motion are relative concepts. This means whether an object is moving or at rest depends on our frame of reference, the observer's perspective. Now let us talk about distance and displacement. These sound similar, but they are quite different. Distance is the total length of the path traveled. It is a scalar quantity, meaning it only has magnitude and is always positive. Displacement is the shortest path from the starting point to the ending point. It is a vector, so it has both magnitude and direction and can be positive, negative, or zero. Here is a concrete example. A person walks 3 kilometers north, then 4 kilometers east. The distance traveled is 7 kilometers, but the displacement is only 5 kilometers northeast. Speed and velocity also sound alike but have crucial differences. Speed is distance divided by time. It is a scalar, so it only tells you how fast something is moving, not the direction. Velocity is displacement divided by time. It is a vector, so it includes both magnitude and direction. We also distinguish between average and instantaneous. Average speed or velocity is calculated over an entire journey. Instantaneous is the speed or velocity at one specific moment. Finally, motion can be uniform, meaning constant speed or velocity, or non-uniform, meaning the speed or velocity changes. Uniform motion means an object covers equal displacement in equal time intervals. A car driving on a straight highway at a constant 60 km per hour is an example of uniform motion. Non-uniform motion means an object covers unequal displacement in equal time intervals. A car accelerating from rest or braking to a stop is an example of non-uniform motion. Acceleration is the rate of change of velocity with respect to time. The formula is acceleration equals the change in velocity divided by the change in time. In short, A equals V minus U divided by T. Positive acceleration means the object is speeding up. Negative acceleration, also called retardation or deceleration, means the object is slowing down. The unit of acceleration is meters per second squared. There are three fundamental equations of motion for uniform acceleration. Let us derive them. The first equation is v equals u plus at. We start with the definition of acceleration. Acceleration equals change in velocity divided by time, or v minus u divided by t. For the second equation, we use the concept of average velocity. Displacement equals average velocity times time. Now substitute v equals u plus at into this formula. We get s equals u plus at divided by 2 times t, which simplifies to s equals u times t plus 1/2 a times t squared. The third equation is v squared equals u squared plus 2as. We eliminate t by combining the first two equations. Distance-time graphs are powerful tools to visualize motion. Let us learn to read them. If an object is stationary, its distance does not change with time. The graph shows a horizontal line. For uniform motion, the object covers equal distance in equal time. The graph is a straight line with a constant slope. For non-uniform motion, the object covers unequal distance in equal time. The graph is curved. The velocity at any point on a dt graph is the slope of the line at that point. For a straight line, the slope is constant. For a curve, we find the instantaneous slope by drawing a tangent line. Velocity time graphs show how velocity changes over time and reveal important information. If an object moves at constant velocity, the vt graph is a horizontal line. If an object has constant acceleration, the v minus t graph is a straight line that is not horizontal. Here is a key insight. The area under the vt graph represents displacement. For acceleration, the area under the vt line is a trapezoid. Displacement equals the area of the trapezoid. Let us practice reading and interpreting graphs with a real problem. In part A, the graph is horizontal. The object is stationary at 10 meters for 2 seconds. In part B, the graph is a straight diagonal line. The object moves from 10 meters to 22 meters in 3 seconds. The velocity is change in distance divided by change in time, which is 12 meters divided by 3 seconds or 4 meters per second. In part C, the graph is horizontal again. The object is stationary at 22 meters from 5 to 7 seconds. Now let us sketch a VT graph for this same journey. So far we have talked about motion in a straight line, but what happens when an object moves in a circle? In uniform circular motion, the speed is constant, but the velocity is not constant because the direction is constantly changing. Since velocity is changing, there must be acceleration. This is called centripetal acceleration, and it points toward the center of the circle. A satellite orbiting Earth is an example of uniform circular motion. The satellite maintains constant speed, but gravity pulls it constantly toward Earth, providing the centripetal acceleration. Other examples include a spinning top, a car taking a curve at steady speed, or a ball on a string being swung in circles. So there you have it, the complete picture of motion from the ground up. You now understand how position changes with time, how vectors differ from scalars, and how acceleration reshapes velocity. Whether you're analyzing a car speeding down a highway or a satellite orbiting Earth, these principles are your foundation. If you found this helpful, please like and subscribe for more physics concepts explained clearly and simply. Drop your questions in the comments below and let me know which topic you'd like to explore next. Thanks for watching and keep moving forward with physics.